A very good morning, ladies and gentlemen. My name is Ranjit, and I will be making a presentation titled Developing a Business Plan for an In-University Water Bottling Plant, a case study conducted at the Central University of Technology, South Africa. I've co-written this paper with Professor Herman Vermaak. As an overview, we will look at the introduction, how the market conditions were explored, how the technical feasibility was conducted, how a marketing model was formulated, and a production plan was developed. South Africa receives 490 millimeters of rainfall annually. This is on average about half of what the rest of the world receives. 9% of this rainfall goes into rivers and surface water, while 4% recharges the groundwater. The groundwater is usually abstracted using boreholes. Boreholes are very expensive to erect and are usually not used by households. This paper examines the business scope of a water bottling plant using the borehole resources of the university without harming the water table or exploiting the groundwater resources. As an exploration into the market conditions to see the feasibility of this project, the study is firstly conducted with the agreement that the management of the university will provide a working capital, land, authorization from the concerned regulatory bodies. The Center for Sustainable Development of the university will oversee the project to ensure that the project does not overexhaust the natural resources. To ensure that there is a market for the product, the business intends to sell and study of the competitors selling the same product in the vicinity, and this is described in Figure 1. As seen in Figure 1, it is seen that the university is surrounded by small-scale retailers who sell a variety of products similar to the one that the university intends to manufacture. This could prove to be a challenge if the plant is looking to service a broader market in its infancy, as the competition will be very high. The advantage in this case is that we can try and service the university where there are no vendors within the university campus, and hence the plant can target students and staff of the university, which approximately amount to 13,000 people. Based on this market condition study, we moved on to a technical feasibility. The technical feasibility was achieved using MATLAB Simulink. On MATLAB Simulink, a model was created with three major blocks. Firstly, the water storage unit. Secondly, the bottle manufacturing and storing unit. And finally, the water filling unit. Gave a successful scope output showing that 500 ml bottles could be manufactured and filled within under 10 seconds. That a marketing model and a sales strategy could now be developed. And this was done using the McCarthy's 4Ps strategy. The McCarthy's 4P was used and preferred due to its simplicity. The 4 P's in McCarthy stand for the product, the price, the place, and the promotion tactics. The marketing model and the sales strategy continued. In the context of this water bottling plant, the product will be a pure 500 ml still water with plans for adding flavor at a later stage. Now, with regards to the price, it has been calculated that the average price of a 500 ml bottle currently is R6.50 or 45 American cents. Now, to gain entry into the market, the product needs to be sold at less than this price. The product would be firmly sold on campus, which, as stated before, has close to 13,000 students. Labeling and promotion will be done in university with the different departments or faculties of the university engaging in the process. The university's radio stations and internal online student magazines will be used as promotion as well. The next plan is to develop the production plan, and for this a three-dimensional model was created where you can see the blocks A to H, where purification, storage, bottle manufacturing, water filling, bottle capping, bottle labeling, the packaging and the palleting of the bottle is described. To conclude, the plan is to utilize the borewell resources of the university to create an in-house water bottling plant. The market study showed that the bottling plant would succeed if catering to the staff and students of the university, which amount to about 13,000 initially. A successful technical feasibility was done using MATLAB and Simulink. A marketing model was developed using the McCarthy's 4Ps. And the production plant was developed using a three-dimensional model. I'd like to acknowledge and thank Mr. Fabian Mile, who has been able to conduct extensive research into the marketing and production aspect of this project, the RGEMS research unit for providing funding and expertise for the technical feasibility, and the management of the Central University of Technology, Bloemfontein, for allowing us to pursue this project. Thank you for your attention.